Okay. That was a little embarrassing. I messed up the go live button. I swore I pressed it, but then it like got grayed out. So this is YouTube Chama being annoying. Anyways, since you missed that, I beat the control router. So Mr. Sun is coming up with some sort of plan. No one knows what he's working on, but it's for something, some super secret, top secret project. You can look at my really shitty design, the one where I put everything I had into it. Very expensive, but I just copy pasted the same code for both of these together. Not exactly very efficient, but does the job. Let's move on back to here. Hi, Chama. Yeah, I did the thing where I didn't press the go live button. Or I did, but it didn't work. Anyways, so I Ching. It's getting a resurgence in popularity. It's because of The Man in the High Castle, that one drama where the Japanese guy is reading the I Ching. Hexagram, 6 lines. Okay, whatever. Quick way to generate hexagrams. Ooh, hexagrams. Okay, this looks complicated. Let's just figure it out. In a mems. Ooh. Okay, so there's gonna be a miniature microelectronic I Ching in a box. Oh, you were here. Good. Yeah, you should have said something. I was here the whole time. I did the whole design. I did the whole design and didn't even stream the entire design. At least it didn't take me very long. It would have been a little bad if I took hours to finish the design and then realized that I didn't press the go live button. And hi Scan Chama, I'll say it again because you didn't hear it last time. Button Oracle has simple inputs connected to a MEMS-based Oracle engine. Ah, yes, MEMS. MEMS is so cool. Nice, I Ching. Yeah, you can say Ching, and it's okay. It's not a slur anymore when you say Ching. Button and Oracle are simple inputs connected to MEMS-based Oracle engine. Display is a display output. Okay. When button is pushed, the Oracle engine will generate 6 values corresponding to 6 lines of a hexagram. When the final value is generated, the display should be updated to match. Okay. Oracle simple input. Button. Oracle. Are you gonna tell us how to make the display look like this, or what? 1, 2, 3, 4, 5, 6. No, I've actually read I Ching and tried the divinations. It's kind of interesting. Oh, that's really cool. Is it hard? So I assume it's just going to be 1, 2, 3, 4, 5, 6. But how does this simple input? It's once it ends. It's 1, 2. From the bottom. Bottom first, and then top. Okay. So this is definitely a use of this thingy. Expand on. I'm not gonna make a mistake of what I did last time and not expand on. It's super easy. Throw coins or whatever item. Consult book. Ooh. Sounds about right. Okay, so what I'm gonna need to do is I'm gonna need to remember these and then put them back out there. So I need to remember two things. Remember like the first 3 and then the second 3. That's pretty much what's important. And it's just 6 times, so I don't need to do any comparisons. I just need to read 6 datas. Okay, so this seems like an actually pretty easy. Where's my button? Oh, the button's right here. It's in one. Nice. This chip has a button and the I Ching built into it. But I'm kind of curious. I wonder what would the MEMS thing do? I guess the MEMS thing will flip coins. Does it make a difference that it's Ching squared? Does it make a difference that it's MEMS, or does it, like, if you just used a RNG, would it make a difference? So how am I going to remember? I'm going to just remember them in the MCX. Easy enough. I need to remember, well, I need to do 6 reads. I need more than 2 memories. So let's just read the memory chama then. Will it fit in, this is RAM chama. Will this work? This is a little tight. You know what? I'm just gonna do the lazy route. I don't want to bother with this whole complicated thing. Let's do it quick. Quick and dirty. I don't have time to come up with a more complicated design. Well, I said that, but I'm a little low on room. I'm gonna offset these chips. Throw money at the problem. It's all about development velocity, you know? So just do this. I'm gonna do it like this. Can I slip under? Like this. Like this. Okay, and then we'll just do the other one with some of these things. How do you like my wiring? It's beautiful, right? And of course, I'll just copy pasta the same code into both of these. So this is the first 3. So what I just do is I'm going to wait and then... yeah. Easy enough. The more money, I make it easier. Solve the problem with money. So I just first need to check until button simple input is 100, and then I'll run the program. So, okay. I'll just skip out if it's not. Like so. Then we'll just read these 3 into the thing. So I'll just digit. How do I use digit again? I should learn it. It's a very important thingy under arithmetic, right? Digit. 0. Oh, digit DST, digit set. 0 is the 3rd digit. Well, I mean, it doesn't matter here. Right? Well, it does, but if I get it wrong, I'll just switch it around, you know? DST. Digit 0, and value is going to be the value... Oh, but it's not 0, 1. It's... to the value... But this is going to be 100, which is annoying. That means it's going to take 2 thingies to check, to like set the digit. Unless I used another one of the... No. I'm not going to use another one of those. This is fine. This is fine. Should I use a loop? I should use a loop. Okay. Okay. Is this 0 indexed or 1 indexed? Off by 1s are the bane of my existence. 0. I'll just start with 0. This, then I'll just do zero. I'm just gonna get. Oh, it's from ACK. Digit get isolates the digit in the ACK result register and store the result. Okay, that's annoying. And digit set only sets it in the ACK. Oh, okay, so digit's kind of not as good as I hoped it would be. But at this point I can, like, since I have a loop, I have a loop, but ACK is my accumulator. Okay, digit is not as good as I hoped it would be. So I won't do a loop. I'm just gonna do 3 things. It's gonna cost me 6 or 7 instructions, but hopefully it works. I think it'll fit. I think it'll fit. My foolish approach. Okay, so I'm just going to Oracle, which is P1, 0, 100. If it is, then I'm going to do digit set, value, digit number, which is 0, 2, 1, minus, like this. Is this foolish? And then I'm going to do slip 1. So I just need to do this 3 times. Will it fit? And of course, and we'll just keep that slip 1. Oh no, but I don't even have my output code, so this doesn't work. This is dumb. Really, just if I could turn this into a numerical number, it would be a lot easier. So I'm just going to use one of these guys. Well, this is the only thing that converts simple input into numerical, right? So I'm just going to stick one of these in between. Then 0, 1, 2. I'm going to check this. I want this to be on the correct. And then of course it turns into an XBus, which actually makes this easier in some ways. It makes the wiring easier. Okay, I'll rearrange everything. So I want it to be 1 when it's 100. So let's take a look at this chip, the IO expandonger. Give me that expandonger. Okay, and I have to remember these pins are numbered, and it changes when it's upside down. P0, we want it to be P0 is 100, makes XBus. When XBus is 1, P0 is 100. Okay. So we want to connect P0 to the thingy. I'm actually going to look at the pin numberings. So connect P0 to the iChain. Like so. Then I just need 2 of these big ass MCXs. Throw money at the problem. So this goes here. And, this will get connected to a thingy. How do I get this across? Let's just think about this first. I just need two of these. these separately. It'll be more elegant that way. Okay, and then like so. And we just do it like this. And we're good. Just like this. Excellent. This is gonna work, right? I think it'll work. Okay, so let's write the code now. Okay, so now we can just move these directly with digit. So dist x1 ac. No, 0x1 slip 1 dist 1 x1 slip 1 dist 2 x1 slip 1. So we do this, we put everything in ac, and then all we got to do is we don't slip 1 anymore, we slip 3, then we just mob x ac x2. Everything should fit and should be beautiful, hopefully. Oops. All right, let's see. So the bottom two worked, nice, and then also the bottom. Okay, so the bottoms are working. So we're just gonna need to do the same thingy on the top. So we'll just copy pasta the entire thing and just change it around a little bit. It's my favorite strategy. Okay, so here we'll just do slip 3 and get rid of this slip 3. Nice. There we go. I Ching. I guess digit and dist is really powerful, but you just need to know how to use it. Okay, so let's move on. That was a nice side thing. Splendid. How wonderful such a device was created right here in China, where it all began. Yes, somewhere where made in China quality is actually more quality. David is more Chinese than even a Chinese person. Yeah, he's got the David P. Solomon with the Chinese in it. One of those chingaboos. Thanks. Wink. Okay, let's move on to the next thing. Ooh, what's this? I never heard of PGA 33X6, but Pushy Stall vendor nearly stuffed these in my pockets as walking through Hua Qiangbei last night. No idea what it was saying. Have some NAP undocumented chips, I suppose. Well, I guess I have a bunch of them now. If anyone can figure out how to make use of it. PGA 33X6. Is that the one that... Do I have a... Oh, that's the the FPGA thingy. It's the thing. It's all in Chinese. Well, it's pretty clear what it does just from looking at it. But it's too big and too expensive for what it does. For what it does, also. Anyways, let's hear about this. Are you aware of the system of precise dieting? Let's ask Google Translate what that means. All right, Google Chama OBS reps please. I need to use this thing. Chinese. These characters. Doing handwriting's input is always an experience. Oh no. My PC Chama is so unhappy right now. Why are you unhappy, PC Chama? Do I have too much shit open? I must. Let me close this thing. Anyways, so we will find out what this word means. Oh, I need to do my OBS reps to make it actually show. It's like this. Yes, the Google IME is like black magic. It can decipher this sort of thing and still get it right. And this is just drinking, like, you know, this. Wait, no, not that one. It's, I'm being so... It's just this character, you know, this one. It means drinking, and then eating. Okay. Is this a real word? Oh, it's even got a website. Well, I haven't heard of it, but well, it also doesn't like me. Anyways, let's just hear the game tell me about it. OBS Chama, where are you? Go away. Turnaround in China has people across the globe measuring down to the milligram what they put in the bodies based on ancient principle of yin yang. Ah, yes, yin yang. Actually, my fiancée, Xiaomei, and I have been trying it for the past months or so ourselves. It really boosts our stamina. I believe a portable food scale aimed at precise dieting community would do quite well. Stamina. Oh, stamina. What does it mean? What does it mean? This one should be pretty easy, right? Just weight and button. Weight is a simple input connected to an electromechanical scale calibrated for grams. Button is a simple input connected to a power/0 button. So it's just going to 0 and displays X plus display corresponding numeric LCD screen. Scales initially off, can be turned on. Ah, yes, it's always actually on, but it's not really on, right? When scales on display should be updated with the measured weight. And does it have to turn off automatically? If a display is showing a value other than 0 when a button is pushed, the scale should 0 itself, so the current weight is 0. This is going to be a pain in the butt. Sort of. Wait. So we need to remember sort of, we can just remember the weight that we saw. We need to remember like a few states. We need to remember 2 states. So I think it'll be fine if we just use one of these. It'll work, right? I'm overestimating myself. So we need to remember what, I guess we'll just say what display is displaying will be one thing we remember, which we'll put in ACK, and then, doesn't seem that hard. I see have to remember the weight. Yeah. We do have to remember the weight. And I guess what we also need to remember is whether or not it's on or off. we need to actually remember if we're off, because if we're off, we only need to turn on, which that part's annoying. The off part, offness. I kind of want just another thing to track offness. Like this will be the tearing machine, and then we'll just have another machine that makes it turn off. But then we can't use slicks because we needed the... No, we can. We have a sort of race condition, but it should be... Because we're just gonna put something out. Something's gonna come out of X2 every single time. And then this will just be my screen offer machine. So sort of the always on Internet of Shit thing, where it's always on, but then we'll turn the screen off. So let's just make sure this, well actually I can always make a bigger chip to make this work. It'll work. No, but this thing needs to know if this, does it tear? When scale is on, display should be updated with measured weight. When button is pushed, scale should zero itself. So I guess the big question is, does it zero itself when it's you know, when it's turned on initially, does it zero itself? I'm gonna just assume yes, it should. It should zero itself when it's turned on initially. Actually, this should tell, oh no, it's zero. Will it give me more? We'll just hope it works, and then if it doesn't, I'll have to change my strategy. This is the problem when you work with incomplete specification, then you have to fight the autograder. Fighting the autograder is one of the worst things ever. Okay. So let's go. So just every time we're going to update this and check P0 and zero it out. Otherwise I'll just maybe have like some dumbass flip-flop. Tell if it's on or not. Well, this could get really dumb, but let's not worry about it just yet. Okay. So if it's 100, then we're going to do the zeroing process, which will just involve dumping this P0 value into, let's say, dat. Yeah, okay. P1 dat. Okay. Now we're gonna, that's the offset. Now we're just going to do the actual loop of P1 act sub dat. And we'll just shove this into the next step. Act X2. I can even use a smaller chip for this. But whatever. Okay, so this will dump this over here to X2. That's the fun. That's it. Let's do this chip. So this will be the zeroing chip. So ACK will be whether or not the screen is on already, let's say. So let's just do this logic. I guess let's start with a big chip. I don't want to have to bother messing with this more. Let's just say dat is on. Well, we can just actually toggle it. So toggle ACK. We'll just put it in ACK because there's no reason to put it somewhere else. Okay, so let's say the condition for toggling is the screen is on. The screen is 0 is the first condition, and then the screen being. So let's just put this like that. First condition is screen is 0 and on. Otherwise, the screen is off. Either the screen is off or the screen is 0 and on. Okay. Off or 0 and on. Those are the conditions for toggling. You know, let's do it the easy way. So. We could change it around if we have to. If it's 100, then we're gonna do on side. Okay, so off condition. We'll just actually we'll do like this. Compress it a little. So this is if it's on. Now we check if it's 0. It's a double condition, right? We know it's on already, so we just need to test if the button is pressed. And 0. There's three things. This makes it annoying. I'm being very silly here. So we only break out if it's, you know, we just have like, so if we're, well, let's just do this part. So if we get here, the screen is off, and then we just say, like this. Button, which is P0 100, and then if it is, then we're just going to move on to the on section. So now the screen is on, but like it's not the same on, because here we still have to do the challenge. We're gonna check the button again, so like we'll have like on 2. That. Okay. I think I'm being very silly here, but whatever. Okay, and then so now, like, we'll just check this and then just jump out if it doesn't match. So that's the button's not pressed. Now we say that 0. Okay, and then this is like we're not on anymore. So wait, why am I? Because we need to get out. We can't just go straight to the on block here. that's not a dash. Like this. This is gonna be a company switch. Okay, so here it's transferring dead, just do 999. We still need to go to end. I don't fit. Well, this is such stupid logic anyways. So I just need to skip this deadness check. Toggle it on. This is the on check, and then this is the on if we're actually on. These three-phase checks just kill me. I wonder how the real programmers do them. Anyways, 0, 100, 0, 100. I think I want to have like a separate condition. I need to just toggle a variable instead of doing I always try to keep a state in the instruction register, which sometimes works and sometimes doesn't. No, this is probably right. So I do this and then, but these two, can I make this better? Being so silly here. So test this. I don't even change. Wait, no, I don't even change ACK. This is not gonna. This whole approach is dumb. Okay, let's start clean here. I need to think more. I kind of want to use logic. I kind of want to use a flip-flop. This is a stupid idea. This is a stupid idea. But it might just work. This is no. I just need to make it work. I just need to make it work. This shouldn't be that hard. So essentially, I want a block at the end. Like I need to just like turn on like this, like, and then like turn off like this, and then like this, and wait, does this not fit? Right, but I don't actually even remember like what my current state is when I do this. This is Right, this is overly complicated and not really helping me much. And then this doesn't even update anything to tell me, to let me know if it's on or off. Which is a problem. Like, I would need a whole nother instruction to do that. Like, so, so if I did another instruction, like, I would, like, have to do something like this, right? And then I'd have to do, like, right, well, I guess I could just make, like, I could jump there from there, but I could also have another thing like this, right? Like that, right? Right, and then I just need to set ACK. In this above block, I just need to set ACK in the correct way. Maybe I need to draw, like, a diagram. Well, I have 3 things to look at. I need to look at DAT. I need to look at ACK and P0. I need to draw, like, a table. P0, okay. Do my Excel reps. So only dat ACK and P0 is, if P0 is 0, we just continue. Then this gives us a few lines to decide if we want to toggle or not. So let's say P0 is 100. Now its dat is 0 and ACK is I'm gonna draw a chart. Okay, let me do my MS Paint reps. I'm really dumb when it comes to this logic sort of thing. Okay. Okay. No. We already know ACK. This is not ACK. Okay, so wait, what? Oh, no, we already know P is non-zero. This is ACK. Okay. Okay. Okay, so and then P is output. No, P is new ACK. Okay, so if it's off and then it's a 0 value, well, these just become on. 100, 100. And then okay, these both set to 100. And then this one is 100. And this is only 0 is here. Otherwise, it always turns on. Just this is the turn off situation. Okay, so this makes an easy check. Okay. I really hope the scale auto tears when it turns on. It's got to, right? So we just turn this, we just want to pair up at the 0 right here. Well, like that, okay. And then oh. I just need to skip this part. Oh, that's annoying. Just stuff doesn't fit. Like if I do this, and then I want to do I still do just doing the double check, and like I still need to set it to 100. Let me do this the other way and like consider if I need to toggle or not. So ACK changing changes are going to be change values here and here as XOR, right? No, and these three are changes. It's only this corner that's not changing. Okay. The corner that not changes. Wait, what? 100 stays 100. No. Yeah, so 100 stays 100 here. Otherwise, it changes there or changes there. Okay, so it only changes in this corner. No, it only stays in this corner. It changes every other way. Okay. Well, I still have to. Oh, that's okay. So. Okay means no change. So I just faulted. Okay, so I'll just make ACK like instead of 0 and 100, just make it negative 100 or something. Well, this doesn't have a good starting value though. Oh no, I can't toggle its Boolean value easily. it fit, right? It's just two conditions. Why can't I make it fit? The 100-fying. Maybe if I just merged it here. If I merge it here, it might work. No, I mean. So I remove this thing and just have turn on and turn off. It takes more lines, but it should be fine. No, but then I need to know. I still need this thing. And turn off is this. I could just do here, like if I just stuck in like here, and then I just jumped there directly from these situations. That, and then I just need to test that. If it is 0, I'm going to also jump to turn on. If it's non-zero, I jump to turn on. Otherwise, there we go. It fits, but it's probably not right. Huh? No, it's not right. It doesn't fit because I didn't do the act. I mean, I didn't move it. I didn't move X1. I think this approach is not... Also, MS Paint is still in front. Oops. I think this approach is just not reasonable given the equipment I have. I think I have to use something else. Like this thing. This is a really dumb idea. No, I should not use this thing. Or should I use this thing? It's got just a number of things, you know? Should I use the forbidden chip? It's so expensive. And I'm still gonna need I'm still gonna need another one of these too. And I still don't even know if this is the right approach. Oh, I hate this problem so much. This whole screen toggling thing. Why does turning the screen off such a difficult task? Okay. So first, I'm gonna put a chip here. That's just gonna, let me move this all this stuff over a little. This chip is just gonna tell me if well, you know what? Let's just test this first. All right, all the screen-ons do work. Well, as far as I know, except for those things, but except for whether or not I need a tear. Okay, so I'm just gonna put this here. And then what this is gonna do is it's also gonna output a special it's gonna output whether or not the screen is on or not. And then this will be the actual screen or turn or off chip. And then I'm gonna use the forbidden chip over here like this, and then this can go back in. What does this do again? This is just a toggle. This toggle is this output or input? Oh, I guess I don't really care if it's input or not. Okay. Don't really care about that. So I just stick that there. So this will just be like whether the screen is off or not. And then I'll just fire it up like this. Overkill for this situation. Then I can just do the whole logic gates like so. So I'll just do mob this x0. Oops. And then okay, perfect. And then I'm just gonna do this one, and it's gonna check this thing. If it is, then I'm gonna do if it's zero means off. Let's say it means off. Well, I can always change it. To x1, otherwise x0 null. To x1. Okay, and then slip one. I'm gonna use slip one here too. Of course, so this part works. I just need to make this thing. Wait, does this part work? Does P1 work? Oh, I also need to move 100 to P1. Also, make this like a blue key. So I'm gonna do that here. Oh, I did make 100 to P1. So. Huh. Oh, this is whether or not it's 0 or not. Okay, so it should. Yeah, P1's on. Okay, so now I just need to do this abomination. Yes, I need to do the highly Chama. Yeah, I'm gonna use the forbidden chip. Now I just need to make it work. How do I do this again? you wanna help me out a little here? So this wire is gonna be. Wait, oh, this is a set SR. So data is. This is just a flip flop, right? This isn't a unique. So I want to use. I want to use the bottom one. This is the regular. Because I don't. This is set reset, right? This isn't just a regular. Like, that's how I get data set. I should maybe play with this in the sandbox first. Well, let's think about it first before I... Okay, so data is whether the screen is on or not. So I actually... Does data just... Oh, this is a... Yeah. I want to know data. Okay. Like that. So I can set the screen on. Okay, so this is the screen onness level. And now I just have a... And or. So we'll start here on our first conditions to set the screen is on. Okay, so first we want to wire up this thingy, the button. It's going to be part of the AND gate. So I think like nothing matters unless this, well, yeah, nothing matters unless the button's on. So we'll just shove that in the AND gate. It's an easy one. And then this is whether or not ACK is 0. So we're gonna figure out reset first when we're going to zero out the thing. So we zero out the thing when the screen is when the value is 0 and the screen is already on. Now we zero it out like so. Now we want to do the same. So we wanted to, that turns the screen off. That's the only condition that turns the screen off. Now, when do we turn the screen on? We want the screen to be off already. So turning the screen on is when the screen is off and this thing doesn't matter. And the screen is off. Okay, this should work, right? No. That didn't work. Did I ever set data? I did set data. Well, first this is 100. So when it's 100, I want it to be the opposite, right? Because it starts off. So okay, so it almost worked. Let's figure out what I did wrong. So this button press should turn the screen on. So regardless of this value, the button press should turn the screen on. So button press, screen being off, I could just clear that. So really just any button press should set, screen being off, screen off, button press should set data. Oh, cool. These lines like blink up. Anyways, so this activated and well, I don't know how to read these lines, but this line is activated. So it set data to 1, so then the 0 should come. Do we have a race condition? Race condition. We do. Well, you know how to fix that, right? There we go. Oh, is it gonna work? That didn't work. The screen didn't turn off. You want a 0? It is still 1. Okay, so the screen didn't turn off, even though it should have. So, oh, P1 being what does P1 represent again? P1 represents the screen being non-zero, so this should actually be the opposite, right? Screen on if off, screen off if 0, screen off if 0, yeah, screen 0 if greater than 0, yeah, yeah, basically, that's what it's supposed to do. Oh no! Did I... This thing doesn't latch, does it? Oh no, this thing doesn't latch, does it? Uh-oh. Uh-oh. I've caused a bit of a oscillation here. Power 1.2 million, nice. I need to connect this to some sort of clock pulse. That's annoying. Like, because it's circular, it doesn't stick. Like these, like, it's like you held the button down and then it just turns on and off constantly, which is not what I wanted to do. Like, I wanted to turn on and then stay on. I thought it would latch. I guess there's no reason why it would latch. There's no clock. Doesn't it make this chip a lot worse? Oh, shit. That throws away this whole dumb strategy of using the forbidden chip. Let me think. Can I make it like? Can I make it work? Like, I only want it to operate once. Like, it changes data and then it just keeps changing. So that makes it. It really is useless, isn't it? Like, this is not going to work, but we just needed to do this, like turn this hold into a pulse. This is a dumb idea, but why not, right? Wait, did it really work? Did it work? It worked. It worked. It worked. My shitpost chip worked. Oh. Oh god. That was so dumb. Scott, amazing. Yes. Well, I've used the forbidden ship now for real, and that was an experience for sure. Yeah, an experience. Okay. Splendid work. This is truly essence of dieting in electronic form, and another great example of confluence of ancient wisdom and modern technology. I'm excited not only to introduce this product to the world, but also for Xiaomi and I to use it ourselves. Whoops, sorry. I know not everyone here can read the characters. Hey, you're working in China. You better learn. Better learn at least the small, simple characters. You don't have to be such a chingaboo, David P. Solomon Chama. Die away. Die away. Okay. Let's continue. We get a new, oh yes, cleanse your body of harmful nanoparticles. Remove stray carbon nanotubes and other nanotoxins from your body with herbal nanoparticle cleanse. Oh no. US $30 value. I imagine still using US dollars at this point. Shenzhen days is the point of it all. Ooh, this is important. So I've talked about the scale of things here, capacity in all these factories and ports and markets, and I've asked, where's all this going, you know? Going? Not to get all existential on you, but it's an important issue and one that crop up after big economic strides. In a sense, yay, we did it. After a lot of hard work and sacrifice, we've secured a hugely important place in the world. So now what? Call me some kind of nutter, but engines of creation like these, the ones we have here, just haven't existed before at this scale. It's only now dawning on us what could be done with them if we started coordinating them all. What if someone with some imagination were to start doing that, putting the whole city to work on something together? What could you build that way? Something gigantic and amazing, or something gigantic and scary? Ooh, maybe a bit of both. Let's ponder on that one for a bit. Yes, this is probably related to this Sun Haotian's secret project. It's, we're gonna learn about it, aren't we? Soon enough. I'm wondering, I'm curious what his secret project is. We're gonna find out eventually. Now let's take a look at the next one. We partnered with a major financial services company to create a cryptocurrency deposit terminal for people concerned about their turbulent financial, shit coins. Should do especially well in regions where people are worried their government-issued currencies may be devalued soon. Yes, of course. Like America. Oh, China crypto, oh no. Yeah. Chinese shit coins. Terminal reads an account number from a cheap magnetic stripe card, accepts a cash deposit, and sends the information to the bank over the internet. Because nearly all the money is flowing in a single direction, we just need to handle deposits. Yes, because no one wants those shitty fiat currencies. Shit coins. Well, shit coins are shit, and shitty fiat currencies are shit too, right? Difficulties. Ooh. This is going to be a pain in the butt. Is this going to be just like the coin op thing? Card readers non-blocking XBoss. Cash 20, cash 50, cash 100. Simple inputs connected to a mechanism that accepts and detects 20, 50, and 100 bills. Network is an XBus output connected to a network interface. User initializes by inserting their account card. User then inserts money. And user finalizes a transaction by ejecting their account card indicated by a value. Is this the part where you siphon the fractional cents to your own account? No, I think it's going to be way easier. We'll just take a 30% commission on all deposits. That's pretty normal in the shitcoin world, right? 30% commission. Okay, finalizes by ejecting the account card while transaction is finished. 8-digit account number and the total amount of deposit should be transmitted over network to the bank. Yes. Susan I.O. Yes. Susan Chava. Susan Hate. I will never give Susan my money. Not even once. So this is a perfect use of Ram Chama, right? So we'll have to use Ram Chama to memorize the account number. And then we can use 20, 50, 100. So here, I want to turn these into, just use this thing. And next, I will simply, I can use Ramchama to do 20, 50, 100, I think. This is, well, sort of. It's like you did that thing last time where you used Ramchama to look up these currency values, but I don't remember how it's done, you know? So anyways, I'm gonna have a couple chips here. One is gonna be the, well, I think what makes this easier is at least we don't have to worry about the weird output that coin counter had. But I think it would be nice if I use Ramchama here. How do I use Ramchama? I'm gonna, so like whatever it is, I'm gonna have a coin counter here. And then this will be my stripe reader. And Ramchama here. Then, ooh, not enough chips. Not enough wires. This is annoying. It's annoying these things take so much to read. So this is the RAM, and I'm gonna put those in here. I'm gonna take them back out. I need all these pins to do that. Coin counter is a separate chip, but oh, I could just use my simple inputs like that. Oh, this is an awkward spot. I'm just gonna cook this up like this. Alright, well, this wiring is not working. Let's optimize this wiring a little bit. Snake this all the way around. Okay, so how did the coin counter work again? It used some sort of lookup table on here, but like, and we have different values. We have how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 of these. Is 14 like a special number that makes this work? We're gonna, well, yeah, we have 100, 10, and 1. So each mod 14, we'll ask Google what those are. OBS. That's not the right one. I want to ask Google who they are. Google. 100 mod 14. 2, and then 10 mod 14 is 10, and then 1 is obviously 1, right? So just do that thing. Put those there, right? That's the easy conversion. So this is wait, this is 0th digit, okay. This is the least significant digit. Always look at the expander. 0 is the most significant digit, okay? So 20 is going to be 100, which is 2. That, and then 50 is 10, which is 10. 14. That, and then 1 is going to be 1. Right? Let's read how to read the ROM. Okay. And then we just read XBus reference. Okay. Corresponding memory pointer will automatically increment to the next memory location. So we'll have a zeroing out step, which is when this thing I need to think of some signals on this this regular pin. I can't just, I mean, it'll just zero out when I do this. So like output is going to be the thing. Okay. I'll do our thing here. So we just do mob x1. I don't even need to mob. I can just mob x1 directly to d1. Oh, x3 to read it. No, A is address x0. Right. So I'll just put this directly there. Well, I need to check if it's 0 first. Test is 0. So I do need to put it in that. No, I don't, because this is this thing. I can just read it as many times as I want. It's like another register, basically. So these things are overpowered when you think about them. Overpowered for bit deals. Okay. So okay, do that, and then now we just need to do this thing. Address, and then we just add x0, right? No, x1. This is x0 for address. And we'll just add that to accumulator. Seems easy enough. This is too easy. Seems too easy. Just take a look. 10? Right. Must have gotten switched up. 11. 11? There's a $1 bill. Oh. It's still on a $1 bill. Oh. This shouldn't be 14. It should be 50. Oh, the 20 didn't work. Why didn't the 20 work? That didn't work either. Well, let's find out. Let's debug this thing and get it working. So this part worked. Now we get the 20. It's not 0. Move x1 to x0. Okay. Put the address to 1. Oh. It should be here. Okay, and then this is going to be the, wait. Huh? Wait, that's the 20. This is 20. I mixed the 20s and 100s. This should be 20. This should be 100. 50, 70, 170, 270. Okay, perfect. Okay, excellent. So that's the easy part. Now we need to do the hard part. Oh no, we need to do output, right? This should be easy enough. Output. So we're gonna put the thing into there and then zero it out. So I guess we don't have any slicks, or we don't have blocking input, which is annoying. I really wish I had more digital pins. Oh, that's probably the trick of this. What it's supposed to teach me is supposed to like teach me multi-reading from this or something. I just want another digital pin. Because if I do analog, like this pin, it won't wait until it's, I could spin lock on it, but that's going to take too many instructions. I need to do some sort of async communication on output, or I could just knob. I could knob. It'll be fine. Because once I do this, it's just well, there's a timing issue, right? I really want a digital. I really want XBus. So I can just XBus and then make another chip spit out the results. I need another chip. Why don't I have more wires? Why doesn't this have more XBus? Is one for the input, one for the output, card reader, and output. Network. Let's get another chip. Then what's going to talk to what? I want one of these. This will talk to this. And talk to the RAM and just output everything. You know, just easy mode. Because this needs to keep running all the time, and then it only reads from this. So I'll have this writing always. Yeah. Okay. And then we'll just talk to this guy. It's not a wires. Four digitals is so few. Oh. They don't make anything with more, do they? Not enough X-Bus for me. At least this part works. We know that. We just need to figure out how to get it out and then... I could just fill this with garbage, and then that'll get my address pointer back. Then I don't need the address pointer anymore. Which will give me enough. So. All I have to do is fill the rest with garbage. Can I put... I'm gonna put 6 zeros in, which needs a counter, which is, it's not gonna be cheap to put 6 zeros in there. I need at least like a few instructions to do that. I'll just do this. I could have this output the result, but it needs to know the feed. I need to know the feed. Don't have enough digital. Okay, so this gives me the amount. Okay, so I just need to combine the amount and this RAM into one thing. Shouldn't be that hard. And then reset this thing. Still have 5 digitals that I want to connect that I can have like multiple reading from the same writings. if I write... only one person can read this, right? So I can't fight to... I mean, I could fight to read it, but it would be very unfortunate. It wouldn't work. So... just need to come up with some sort of apology here. And these two address points. Like that. Yeah. Okay. And the way this is going to work, this is going to always push... something. I guess it's going to be something. Okay. Actually, I can still do the P's here. Well, whether or not I'm going to do P or X is up to future decision. Let's write this thing. Yeah, I'm just going to do this. So I'm going to just do a gen. But then this is going to go out digital. Good enough. It'll do the job, right? Wait, why did I... No. Right, I don't have X anyways. Wait. Oh, and then I'll just... once I move this, this thing will just wait for this, and then... do this whole thing. Okay. It needs to do the card first, right? Or is it amount first? 8-digit account number and a total amount. Amount is last, which is annoying. I can just slicks and then only do it at the end. Yeah, okay. Perfect. So I'll just do slicks this one and then do 8. So then loop, jump to loop, and then X1 like that, and back to slicks like so. So that'll do my thing. Okay. Now, this last chip is the hard part. I really hope it works. Okay. So, put these in there. Oh, this is non-blocking? It's non-blocking. Non-blocking. Sucks ass. I hate. This is a lot worse being non-blocking. This is a lot worse being non-blocking. Anyways, I guess I could always do this and make it blocking. I'm lazy. There we go. It's not non-blocking anymore. There we go. Well, this is just a little wasteful, but it's just for convenience. Easy mode. Okay, just slicks it, and then we're good. And we just do the thing. X3. So we're gonna set this memory, and then we're gonna talk to Ram Chama. Talk to Ram Chama. Oh, we first need to check if it's -1. So we still have to do this, which I guess means, like that didn't really say many instructions, but whatever. It's gonna be close anyways. Maybe Slicks was a mistake. Let's see what an hack. Okay. Okay, so we're gonna just put ACK in there. Okay, now we're gonna do loop. Loop. And sub. And check. Huh? Huh? Okay. We do Slicks again. Huh? Like I loop and is. Oh. Hopefully 6 is the right value. Nope, it's 7. We got that part done, but now we're a little short on space. We got to zero out this. Then we just do gen. P0. I need to read how to do the gen command. Undocumented instruction. Where is it? Gen P register instruction register okay register okay X Y okay, so X is 1, Y is gonna be 0. Okay, let's go back here. What? Why do we dump stuff out? Well, I guess something's happening. Okay. Let's figure out why it doesn't work. Why did that happen? Okay. We outputted. Oh. Okay. Well, something came out, but it wasn't what we wanted. Okay. It's too slow. By the time this is done, this is already sleeping. So we've outputted everything too late. That's the problem with this sort of weird ass communication method. Okay. Yeah, because this finished already. Why is that so slow? You know? Because obviously these timing problems are a little. So we do slicks x0. Oh, because this has to do. This finishes, and then this finishes. I really want to do X-bus communication with this. So I'll use this X for this one, and then I'll switch this out for a regular chip, and then I won't slicks. I'm gonna wait loop. Spin loop on this. Okay, that'll do. That's good. Strat. So I'll use X-bus. Have to use X-bus on this. Spin loop on that with a P1. Okay. Okay, so I won't use Gen. Just gonna write text one. No, this won't work either. What do I do? So the problem is I never told this in time to, I guess if I didn't have, do I have enough lines to, I know this minus 999? I do. I don't need this thing. I'm not gonna get rid of the slicks. Away somewhere. And then I still have this gen thing, but this will be faster if I can fit it. No. Because I still need to, well, okay, slip, this all loops, so it's okay, I can go back to slip one, yeah. I don't even need to jump to it, I never need to jump to it. If it's 999, then we jump here. Hi, Ryan Chima. I'm needed on my multiplayer Minecraft thing, not bear related, so I'll miss this one. But good luck with your microcode. Oh, yeah. Did you see the part where I used the forbidden chip though? That was really a lot. Anyways, good luck on your Minecraft. Have fun. Face Chima. And then I don't have enough lines. Ah, yes, wave back. I'm waving. I don't have enough lines because I can't do this comparison 999 with one line. So this won't work. I don't have enough space. Put this in the accumulator and then I fill it. I mean, this is the straightforward thing to do. Loop until 0. So I actually have an X bus here. I just don't have an X bus here. So, I can free one up by just using a X bus to non-X bus converter right here. I can just convert that to that, and I'll free up an X bus, which I can use to top. Yeah, that's exactly what I do. This has a free X bus. I just need a free X bus here. It's not about the freeing the X bus, because then it's gonna, I can't use a gen pulse like this unless I write every time. Oh, but I could write every time. Because all I have to do is write, well, I can't slicks, I have to write every time. Slicks. Well, that would get rid of the need for that slicks, but shit. I want to output this, like this. How does this chip? It needs to wait, but not wait on those other times. I just need to make it a little slower. You know what? I'm gonna do a really gay strat. Wait, no. I need hack. Do I need hack? Yeah, I do. This is gonna work, right? I just need to kill some time. And I need to save my value back. Can I kill more than 4 instructions worth of time? I guess I just do 4 nops and hope it works. Did it work? No, 4 nops not nearly enough. Maybe like more. Okay. Can I loop in here? No, I can't. Right? I need a loop. If this works. If this works. If this work. Oh, it didn't work. Oh, it didn't work. Actually, this part, like, it did work. It just didn't, right? So we made it to the pulse. So we outputted the wrong thing. This is reset, so it should output 7. Let's take a look what this thing did. So 70 went in here. 0 to ACK. Or a loop. Moving X0 to X3. Huh? 0, 0, 0. Wait. Where did 7 come from? Oh. This needs to go at the end, just the order of these instructions. Almost, maybe. Well, wait, I never... Huh? I mean, this needs to happen 7 times. So... How did this even... Well, I mean, this is just dumb, I guess. Should be minus. And then, I need to actually... Not mob 0, X should be like 7. For 7 digits. Well, that outputted way too much. We're getting close though. We outputted it twice, didn't we? We did some really dumb thing, didn't... Wait, what? 9? Oh, No, we just kept looping? Wait, why? Why? Wait, why'd I do this? First, I don't need this. 0 to x2. I don't need to do that. Of course, and then this should be 8. If this works... Oh no. It's wrong? Oh, it's not x2. I need to 0 out hack. There we go. If this works... If this freaking works, my kill time... My dumb-ass kill time function works. Oh, it does work. I nailed it. I nailed it. Absolutely. Absolutely nailed. Great. I think we can really catch the wave with this one. Cryptocurrencies are surging. Ah, yes, surging. Thanks to market fluctuations. It seems even people who used to work primarily with cash are giving up and looking for an easy way to convert money to digital these days. Yep. Wasn't there some country, like, in South America that was switching to crypto? I wish I had my own currency. It must be nice to use a medium of exchange that you can manipulate anytime you like. No politics, please, Carl. Ah, Carl. Carl's really a real spoil sport, isn't he? Alright, well, I think that's enough for today. We really did some really jank solutions. like the kill time function with my 666 in the memory here. And yeah, there's the kill time function and the forbidden chip. The forbidden chip. And this dumb pulse generator. Well, yeah, that was today's progress on the Internet of Shit. It is just as shitty in real life, isn't it? Anyways, so everyone, thanks for coming to the stream and watching me, helping me make these really shitty products. I will see you all later.